Okay, these are some more of the Chapter 5 practice tests. All right. And this is number 5. Find the average value of the function of g of x, which equals 3 plus the square root of 9 minus x squared on the interval negative 3 to 3. I use graphs and areas to evaluate any integrals. Leave the answers in terms of pi. Okay. So we had to graph this. I've got this kind of cleared up here. I hope you can see this. So this is over here. This is number 5. And we want to graph this. Now this is my x-axis. I probably should maybe make this a little darker so you can see my x and y-axis, because my graph is actually over that. So this is my x-axis there, and here's the y-axis here. So you can see what's going on. And then this is just going to, if I look at this y equals the square root of 9 minus x squared, if I square that, square both sides, I get y squared equals 9. If I add x squared to both sides, I get x squared plus y squared equals 9. And that's going to be a circle. That's whose radius is 3. Okay, and since this is the positive part, it's just going to be the upper part of the circle, or the semicircle. But the thing is that since if I look at my equation over here, I'm looking for the average value. I'm going to have to find this equation over here. This is going to be shifted up 3. So when I graph this part, this is going to be shifted up 3. So instead of being at 0, this line, this would be up 3. Now if I want to find the average value, remember the average value is going to be the integral from, and I guess we could look at that over here, the average value. Remember, that's the integral from 1 over b minus a, the integral from a to b of f of x dx. Now it says, use graphs and areas to evaluate any integrals, leave the answers in terms of pi. So the problem is that we're going to take this, as the interval is going to be from negative 3 to 3, so this is going to be b was 3 minus negative 3, so those were the limits of integration. All right? And we're going to take the integral from negative 3 to 3, that's going to be my a to b, and this is the function. So we're trying to find the average value of this function on this, over this interval, using this integral. All right? So I have to graph this, and I'm going to use the area to find the value of the integral, because I can't do this without a calculator. Okay? So again, this was a semicircle, but it's shifted up 3 units. So this is what the graph looks like. And I know the area of the semicircle, area of a semicircle, and I can find the area of this rectangle, so I just add those up and I'll get the area under the curve from negative 3 to 3. So that's basically all you have to do. All right? So the area of a circle is pi r squared, so the area of a semicircle is 1/2 pi r squared. My radius is 3, so that's going to be 1/2 pi times 9. Now the area of this rectangle, since this is shifted up 3, this height of this rectangle will be 3, and the base will be from negative 3 to positive 3, 1, 2, 3, 4, 5, 6. So this is going to be a 6 by 3 rectangle. So the area of the rectangle is 6 by 3, which is just 18. So this is the area of the semicircle and the area of the rectangle, so I add these up. This is a semicircle. Hope you can see that. So the area of the semicircle, which was 1/2 9 times pi, or 9 over 2 pi, and the area of the rectangle is 18, so that area of the region is 9/2 pi plus 18. So that's going to be the value of my integral, because it's all above the curve. So the value of my integral was, again, 9 pi over 2 plus 18, and this 1 over b minus a is 1 over 3 minus negative 3, which is 1 over 6, so I'll take 1 over 6 times that. And then what we can do is 3 goes into 9 3 times, it goes into 6 twice, so I have 3 on the top, and 2 times 2 is 4 on the bottom, so I got 3/4 pi, and then 6 goes into 18 3 times, so that was your answer, 3 pi over 4 plus 3. And you did have an answer sheet for these, so that's how you get that. Okay? So I hope this is kind of cluttered in because I worked these solutions out before, but I'm running short on time, so I thought I would just show it to you like this. Hope that makes sense. And if any of these problems give you any problems, you don't kind of follow them, just send me an email, richard_martinez@chino.k12.ca.us, and I can elaborate and maybe do a little bit more detail on these. But if you zoom in, you should be able to kind of follow everything. Okay? All right, let's take a look at number 6. And number 6 is just evaluate this integral analytically using the fundamental theorem of calculus, leave the answer in radical form. So this is the integral from pi over 6 to pi over 3 of secant squared dx. So we're going to use antiderivatives. When we talk about the fundamental theorem, we're going to use antiderivatives. So here's my integral. I think you can see all this. I think this is clear enough. Oh, that's one out. Sorry about that. Okay, so pi over 6 to pi over 3. Now, what's the antiderivative of the secant squared? The antiderivative of the secant squared is the tangent squared. Now that's going to be my f of x, my capital F of x. That's my antiderivative. And then this is going to be the f of b minus f of a from the fundamental theorem of calculus. So my a will be here and my b will be here. So that's going to be the tangent of pi over 3 minus the tangent of pi over 6. That's all you have to do. So you have to know your unit circle. What's the tangent of pi over 3? Well, the tangent of pi over 3 is going to be the square root of 3. And what's the tangent of pi over 6? 1 over the square root of 3. So I've got the square root of 3 minus 1 over the square root of 3. You can leave it like that. You can choose to simplify it. That's fine too. We can simplify this by getting at least common denominator. So if I multiply the top and the bottom by the square root of 3, I've got 3 over the square root of 3 minus 1 over the square root of 3 is 2 over the square root of 3. Then if you choose to rationalize that, you can get 2 times the square root of 3 over 3. So that would be the answer in the rationalized form. Okay? But any of these forms are acceptable because this is the main idea, that you work it out and that you do know your unit circle. Okay? And number 7. Find dy dx if y equals this integral from 3 to negative 5x cubed to 4t squared plus 3t dt. All right, so we're just going to use our fundamental theorem of calculus. It says if we take the derivative, in other words, we want y, well, this integral was equal to y, so if we want the y prime, we have to take the derivative. So y prime will equal the derivative of this. So again, we're just going to, this is going to be f of x. All right, this is my function. This is f of t, but I'm going to evaluate it at this, so this would be f of x, except I do have to apply the chain rule. So this would be 4 times something squared, so that's going to be 4 times, and instead of t, I put negative 5x cubed squared, plus 3 times negative 5x cubed, 3 times, and instead of putting t, I put negative 5x cubed, and then the whole thing I've got to multiply by the derivative of this, using the chain rule, so that's going to be 3 times 5 is 15, so it's going to be negative 15x squared. Okay? So that's what we're doing with this very nice application of the fundamental theorem of calculus. It's pretty easy. Just remember the chain rule. And then if we multiply this, it's going to be positive 25 x to the 6th minus 3 times negative 5 is negative 15 x to the 3rd power, all times negative 15x squared. And then 4 times, so this is 25, 4 times 25 is 100, so I've got 100 x to the 6th minus 15 x to the cube, all times negative 15 x squared. And then if I multiply negative 15 x squared times this, I will get negative 1500 x to the, and then 2 plus 6 is 8, plus, and a negative times a negative is a positive, plus 15 times 15 is 225, x to the 3rd, plus x to the 2nd, or times x to the 2nd. I add the exponents, I get x to the 5th. So there's your answer, negative 1500 x to the 8th, negative 1500 x to the 8th power, plus 225 x to the 5th. So that's just using our fundamental theorem calculus part 1, so I hope that helps.